Okay children, let us resume our classes. Now, till now in 4 parts we have learned the chord properties. Now from part 5 we will learn arc properties. So let me revise once again what is an arc. Okay, I have already told you, discussed this in part 1 while explaining to you the different terms. Now let me revise once again. Arc is a part of the circumference of the circle. So if there is a circle with center O and this is the circumference, then AB is a part of the circumference of the circle. So AB is called arc. Now, so whenever you have one arc, actually you have two, because if AB is one arc, then this part of also will be called AB only, but this will be named as major arc and this will be named as minor arc depending upon the size. The smaller arc is called minor arc and the major one, that is a bigger arc, is called major arc. Okay, they will be named both AB only, but this will be major arc AB and this will be minor arc AB. So usually we represent it as minor arc AB and we write major arc AB. Okay, so that is the representation. Now, also the region bounded by a chord and the arc is called the segment. Okay, so this part, this is the region bounded by the chord AB and the minor arc AB. Okay, so therefore this is called the minor segment. Okay, now again major arc AB and the chord AB, these two enclose this area, isn't it? This is the area enclosed by the major arc AB and the chord AB. Okay, so this region is called the major segment. Okay, now with this knowledge, let us start learning the next theorem related to arc properties. Okay, related to arcs. Now, this theorem, as I told you, according to our convenience, we will be numbering it as 5. Okay? Okay. Now, what does this theorem say? This theorem says the angle subtended or made, the angle subtended by an arc of a circle at the center of the circle. Okay, the angle subtended by an arc of a circle at the center of a circle is double the angle subtended by the same arc, but you need not say, mention it again, is double the angle subtended in the remaining part of the circle. In the remaining part of the circle. Now, this remaining part of the circle is a very important aspect which you must understand. Now, let us first draw the diagram according to the statement and let me explain to you. Okay, so now What does this theorem say? The angle subtended by an arc of a circle at the center of the circle. So that means we have a circle with center O. We also have an arc. Okay. So let us consider AB is an arc of a circle. Now the angle subtended by an arc of a circle at the center. So what it will be? You join OA and OB. So this is the angle subtended by the arc AB, okay, by the arc AB at the center of the circle. Now what does the theorem say? The angle subtended by an arc of a circle at the center of the circle, that means this angle. Basically, with all this long sentence, we are referring nothing but to angle AOB. Now, what is that? It is double the angle subtended in the remaining part of the circle. So, what is the remaining part other than the arc AB? Whatever, that is a major arc. Okay. So, here remaining part is this much. Now in this remaining part, if the same arc AB subtends any angle, so let us take, say, at point C. So which will be the angle? Okay. So this C can be anywhere between A to B. That is in the major arc. It can be anywhere. Now, so according to this theorem, the angle at the center will be double the angle in the remaining part of the circle. So that means basically this theorem says that angle AOB is equal to twice angle ACB. C can be anywhere in the remaining part. C cannot be here. If C is here, then this angle and this angle will not be according to this relation. Okay. So first of all, let us prove this, then I will explain. If there is another part to this also, what about this angle, the reflex angle? Okay, so that also I will explain slowly. But first let us consider this part. Okay, now what we are going to prove? That angle AOB is twice angle ACB. That is the meaning of this statement, isn't it? What is the meaning of the statement? Meaning of the statement is the angle subtended by an arc at the center of the circle is double the angle subtended in the remaining part. So in the remaining part, angle ACB is the angle subtended in the remaining part. Okay. So we will have to prove that angle AOB is equal to twice angle ACB. Now what is given? Given a circle with center O, okay, an arc AB which subtends angle AOB at the center O and angle ACB in the remaining part, okay, according to what is given in the statement, remaining part of the circle. Okay, C can be anywhere in the remaining part. Now what is to be proved or verified? We have to verify that according to this theorem, angle AOB is equal to twice angle ACB. The theorem is already proved. We are verifying whether it is really double or not. So that we have to verify. Now for that we need small construction, that is join OC and produce it up to D. Okay. So construction, join OC and produce it to D. Right? Now Now the proof part. Okay, so now consider triangle OCA, okay, and OCB. In both the cases, let us first see OCA. Now OC and OA are the radii of the same circle. So therefore OC is equal to OA. Then it is an isosceles triangle. So angles equal to, opposite to equal sides are equal. So that means this part of the angle, okay, this part, what is this? OCA will be equal to OAC. Agreed? Similarly, in triangle OBC, OC and OB are equal because they are radii of the same circle. So again, angles opposite to equal sides are equal. So this part, that is angle OCB, is equal to angle OBC. Agreed? So these two are equal, these two are equal. That is what we are going to write. So first, in triangle OCA, OC is equal to OA. Sorry. So what is the reason? Radii of the same circle. Okay. So therefore, what type of triangle it is? Isosceles triangle. So that means angles opposite to equal sides will be equal. So this implies angle OCA is equal to angle OAC, these two. What is the reason? Angles opposite to equal sides are equal, right? Similarly, in triangle OBC we can prove this is equal to this. We need not rewrite again. We can write similarly in triangle OCB, angle OCB is equal to angle OBC. OCB is equal to angle OBC. Again, you need not write the entire explanation, but we know how we have proved. Again, OC is equal to OB because they are the radii of the same circle. So again, OCB is an isosceles triangle. So therefore, the angles opposite to equal sides are equal. Okay. So now, let us consider triangle OCA. Now we have produced OC up to D. So this angle, what is this angle? Angle say AOD. Okay, this angle. Can you make out? Now what type of angle it is? It is an exterior angle. So in your smaller classes, you remember the theorem that you have learned. The exterior angle in a triangle is equal to the sum of the interior opposite angles. Do you remember that theorem? So according to that theorem, this is the exterior angle. According to this triangle, OC is extended up to D, produced up to D. So the angle formed is angle AOD, which is the exterior angle, and it is equal to the sum of the interior opposite angles, that is angle OCA and angle OAC. Okay, so let us write in triangle OCA, exterior angle AOD. Okay, that is the angle formed by producing OC up to D. So exterior angle AOD is equal to sum of the interior opposite angles, that is angle OCA plus angle OAC. Okay, but we have proved that OCA and OAC are equal. Okay, here we have proved. So it implies exterior angle AOD is equal to OCA and OCA, that means twice angle OCA. Okay, let us call this equation 1. Okay, similarly in this triangle, the other triangle is OBC, yeah, OCB. In this, the exterior angle formed is angle BOD. Okay, so BOD is the exterior angle. So this exterior angle will be equal to the sum of the interior opposite angles. Okay, so now according to that, exterior angle in triangle BOC. So similarly we can write, we have proved in a similar manner, so we can write similarly. This is a symbol for similarly, 3 lines and with ly. Similarly in triangle OCB, exterior angle BOD, okay, is equal to sum of the interior opposite angles. What are they? Angle OCB plus angle OBC. Okay, but here again we have proved angle OCB is equal to angle OBC. We have already proved. So that means this is again equal to twice angle OCB. Okay, so we have proved that the exterior angle AOD is equal to twice angle OCA and exterior angle BOD is equal to twice angle OCB. Right? So from this it follows exterior angle BOD is equal to twice angle OCB, because OCB and OBC are equal. So it is 2 times angle OCB. Okay. Now let us say equation 2. Now from equation 1 and 2, exterior angle AOD and exterior angle BOD, exterior angle AOD and exterior angle BOD is nothing but angle AOB, and that is equal to twice angle, this part is equal to twice angle OCA and this part is equal to twice angle OCB. That is what we have proved in 1 and 2. So if you add, what will you get? 1 plus 2, that is equation 1 plus equation 2 will give you exterior angle AOD plus exterior angle BOD is equal to twice angle OCA plus twice angle OCB. That is what we are getting on adding. So this, but angle AOD plus angle BOD is nothing but angle AOD is equal to twice angle OCA plus angle OCB. Now what is angle OCA plus angle OCB is nothing but angle ACB. So that is equal to twice angle ACB. Okay. So that is what we intended to prove, that is triangle AOD is equal to twice angle ACB. So that is what the theorem says, that the angle subtended by an arc at the center is double the angle subtended in the remaining part of the circle. Now let me give you some examples, different questions. Okay, now for example, this is the center, this is the arc AB. Okay, so now if you take a point P here, okay, so according to this theorem, angle AOB will be equal to twice angle APB. Okay, now let us consider another diagram. Now this is the center, AB is the arc. So this is the angle subtended by the minor arc AB at the center. Now the major arc AB is subtended this reflex angle at the center. So according to this theorem, the angle subtended by the major arc AB at the center should be equal to or should be double or twice the angle subtended the remaining part. So what is the remaining part? This small arc, minor arc is the remaining part. So here if AB, major arc, subtend an angle, it will be say at this point, say we call it D. Okay, so the same major arc is subtending subtending the reflex angle AOB at the center. Now the same arc, major arc, is subtending an angle at any point in the remaining part. So remaining part is D can be here, D can be here, any part is the remaining part. Then this reflex angle will be double angle AOD. So that means according to this theorem, in this picture, reflex angle AOB will be twice angle ADB. That is the remaining part. That is why I was telling you remaining part is very important. Okay? Is it understood, children? Okay?